Gerson with a structure symbolizing a satellite in space, otherwise known as the sender, and it will send a signal to the rover or the receiver, and it will move, simulating a signal sent. We are motivated to create this project because we believe it has multiple teaching concepts that can be beneficial to students everywhere. Right, so the principles it teaches is how satellite communications works in real life, the communication between the sender being satellite and the receiver being the rover. We also did some parts with coding on an Arduino tool, and using that Arduino we were able to establish a lot of our moving parts on our rover, which involved putting motors to move the wheels that we put on the rover. Right, in the building process we split into two separate teams, with one team focusing on the satellite part, so they were satellite team, and we also had a rover team that focused more on the building of the rover, of course.
For the rover team, it was composed of Miles and I, and what we were in charge of is building the actual structure of the rover, such as the wheels and the chassis. The main teaching concepts of the rover are how basic physics and some structural engineering work, such as gravity, how that causes the rover to be on the ground, and then normal force can be understood through that gravity, because that's what keeps the rover from going through the ground. And that normal force allows friction on the wheels, and that friction allows the wheels to be able to move the rover forward, backward, or in any other direction. Our original design for the rover did, in fact, involve it having 3 wheels, but through the course of our project, many aspects of our rover did change as we learned more about how to use the Arduino and the rest of the project. Overall, the rover team was tasked with building the chassis for the rover, which would be used to store the circuitries where the Arduino and battery and motors would go, and we were also in charge of designing the wheels. And for our original design, we utilized one that we found from an existing project where the wheels seemed to allow their structure to move. But we later did find problems associated with our exact wheel design. In order to fix the stability problems, we changed our design from having 4 wheels to having 1 caster wheel on the back that was smaller than the front 2 wheels. This allowed the rover to be able to make turns much more easily than it would with 2 stiff wheels in the back.
Hi, my name is Matthew, and I was a part of the satellite team. Our initial task was to demonstrate the signals that are passed through a actual satellite when it's communicating. You can see in our first sketch here, our plan was to have an LED in the middle that would illuminate whenever a signal was passed through. We soon moved on from this and wanted to demonstrate a little more complexity. Therefore, we developed a satellite that would show a signal sent out to the rover. This would then allow the rover to move and communicate back.
Howdy, my name is Gerson. I am part of the satellite team. The main principle behind the communication of our satellite and rover involved the usage of radio waves. These radio waves have the ability to travel at the speed of light and can cover distances very quickly. For example, it takes about 5 to 20 minutes for a signal sent from Earth to reach Mars, covering a distance of about 225 million kilometers. Arduino's simplicity and abilities, along with their extensive variety of libraries, make it really easy to pick up and learn. For our project, we utilized 2 Arduinos, one for the rover and one for the satellite. This meant having 2 sketches. The sketch on the rover controlled 2 motors, a temperature media sensor, and a transceiver. The sketch on the satellite controlled only a transceiver, but it also interpreted commands and information it received. Our initial design utilized IR sensors to control the rover, but it was limited to one-way communication. Having introduced the transceivers, we added complexity to our rover and allowed for 2-way communication. In early testing, we had a few issues. Our initial motors lacked torque to turn the wheels, which led to power issues, causing things to malfunction. To solve this, we acquired new motors that produced more torque at the cost of rotational speed. As previously mentioned, we had decided to use IR communication to control the rover. This, however, severely limited the functionality of our project and did not let us fully implement what we had in mind. Once we had discovered transceivers, we were able to fully implement our idea and add complexity to our project.
Right, so putting everything together, with all of our team members coming together to make some last-minute final decisions, we were able to fix our wheel arrangement onto the rover with the cage with the Arduino inside and start testing its functionality. First few tests made us realize that there are some issues that occur when we run the code repeatedly. The rover will fail to move in some instances. We now have ran the code enough times to ensure that our rover moves whenever we want it to.
After it was all said and done, we were able to implement the improved design of both the rover and the satellite to our project, and all of our testing uncovered many issues we did not initially think we would encounter. Some of them being how the motors were not strong enough, others being how some of the signals were difficult to send, but by the end we were able to get everything together. All the components came together to be able to have a rover that fully functions and a satellite that sends signals to the rover and able to receive signals back from it. We used 2 separate codes, one for the signal sending and another for controlling the motors. And overall, the rover itself uses 3 wheels, 2 with motors, and 1 with the caster wheel on the back. All of this came together to allow our rover to be able to receive signals from the satellite, and in turn, it could return signals back to it to send back information. And the new improved design of the structure and wheels with the caster wheel allow it to turn easily, easier than
네,
with
시간이 다 돼서 요 작동 영상까지 보고
allow it to
질문
better grip
드리겠습니다.
resources than it would
네.
otherwise. Together help us create a final product, which demonstrates the principles of
역시
engineering structure design.
이 프로젝트를 진행한 팀도 미국의 대학생들인 거죠?
네, 맞습니다.
이 프로젝트는 누구를 대상으로 제작했다고 보면 될까요?
이 프로젝트는 최소한 중학교 이상은 돼야 아마 이해를 할 거라고 생각을 하고, 조금 더 깊이 알두이노나 그 세틀라이트 혹은 DC 커뮤니케이션에 대해서 이해를 하려면 고등학생 정도는 돼야 될 거라고 생각을 하고 있습니다.
예. 우리가 예를 들자면 어떤 행성을 탐사한다 그러면 실제 지표면이 울퉁불퉁할 거 아니에요.
네,
그렇다면
맞습니다.
로버의 바퀴가 조금 이 울퉁불퉁한 땅에서도 갈 수 있는 좀 그 형태로 보완되면 좀 좋겠다는 생각이 들었어요. 좋은 방법이 없을까요?
네, 맞습니다. 안 그래도 그 바퀴를 여러 개를 제작한 걸로 알고 있는데, 울퉁불퉁한 거를 구현을 하지는 못했고, 자기들 집에 있는 이제 카펫이나 소파 같은 데서 하는데 보니까는 그거에 맞는 거를 이제 잘 되는 걸 보여주기 위해서 그런 바퀴를 선택한 걸로 알고 있습니다. 그 울퉁불퉁한 것을 하려면 아무래도 좀 더 크고, 좀 이렇게 홈도 이렇게 바퀴 사이사이 홈도 파 있고 그런 게 더 적당한 걸로 적당할 걸로 생각하고 있습니다.
DC 같은 것은 실제로 보통의 DC 구조물을 보면은 약간 방구 형태 DC들이 많잖아요.
네,
근데
맞습니다.
이 학생들이 지금 약간 각불이라 그럴까요? 이런 형태로 제작한 특별한 이유가 있나요?
처음에
네.
스케치 할 때 여기는 한 개만 보여줬는데 구형도 있긴 했는데, 여기 저기 로버 위에 장착하는 데 있어서 아무래도 각불이 좀 더 편한 것으로 아마
실제
해서
장착을 하기 위해서 그렇게 구조물을 만들었다는 거죠?
네, 맞습니다.
설명 잘 들었습니다.
네.
발표 준비해준 학생들에게 수고했다는 말 전해주시고요.